For the function operations, okay, we have actually done everything on this lesson before. Okay, it has looked different in the past. Like in the past, if I wanted you guys to combine like terms, I would just give you two sets of parentheses and I'd have a plus sign between them. Okay, same thing with subtraction. With multiplication, I'd give you like two sets of parentheses. You guys would do a box problem. Okay, so this is all stuff you've done before. The only difference is now there's a different notation because we're talking about functions. So I just need you guys to look up here, and I need you to understand that if you see something today that looks like this, where there is a plus sign between f and g. So this is function f added to function g. Okay, so we're going to take two functions, we're going to add them together. So all this is combining like terms, which we have done lots of. Subtraction. They have f minus g of x. Well, all that means is take function f and subtract function g from it. Again, that is combine like terms. What do we always do, though, with subtraction? Don't we usually turn it into addition? Using what? Yeah, so we're going to do like the keep, change, change first. But then after we do keep, change, change, we will end up just combining like terms again. Okay? So the top two are nothing more than combining like terms. Multiplication. If you guys see this little dot between the two f and the g, that means multiply function f with function g. That is basically just either distributive property, or you might make a box problem. You might have to do a 2 by 2 to do your multiplication. Okay, now division, same thing. You have one function being divided by the other, okay? A lot of times what they're going to do is they're going to give you a number to actually plug in, so that way you'll end up with a numerical answer. But we'll just end up either like simplifying the fraction. I'm going to just write that. We'll end up simplifying. Simplifying could mean factor the top, factor the bottom, see what cancels. Or it could just be they give you a number to plug in and you would actually do the division. Okay, so we're going to go through some examples together, starting with addition and subtraction. Okay, so down here at the bottom, it says let f of x equal 3x plus 8. So here's f, that's function f. And then g of x is equal to 2x minus 12. Okay, so those are the two functions that we are going to add and subtract. Okay, so you're just going to use these expressions is what you're going to do. So for this one over here, when it says, like when it shows a plus sign between them, all we're going to do is take f, which is 3x plus 8. Then you're going to put a plus sign, and then we're going to put g, which was 2x minus 12, in parentheses next to it. Okay, now you guys have all seen problems like this before. If you are adding two expressions together, you just combine what looks alike. So you guys would do 3x plus 2x, which would be 5x, and then 8 plus negative 12, negative 4. Super simple. Add the like terms. Okay, Now, if you see a minus sign between them, pay attention to which one they list first, because it does specifically say to start with F and then subtract G. So you have to make sure you put the 3x plus 8 first. Okay, subtraction order matters, addition order does not matter. So especially with the subtraction, make sure you get it set up right. We're going to take the 3x plus 8 and we're going to subtract the 2x minus 12 from it. Okay, so that's how I would set it up initially. But then, I don't like this. We don't like that minus sign. Most people are good with 3x minus 2x, but it's the other part that people tend to mess up. So I always just say, okay, let's just do keep, change, change anyway. So like, watch please. Keep would be that first set of parentheses. My first change would happen right here. I'd make that a plus sign. My second change should happen in the parentheses. So if this one's positive and this one's negative, this one's going to become negative and this one will become positive. So that's how you do the keep, change, change. And now we just combine like terms. Okay, so we are going to take 3x plus negative 2x, which is a 1x. And then you're going to take the 8 plus 12, which is 20. It really is that simple for addition and subtraction. You are just combining like terms. Okay?
Is this all we're learning today?
All right, go ahead and turn the page. Now we're going to do some multiplication and some division. Okay, so up top it says let f of x equal x squared minus 1 and g of x equals x plus 1. Okay, so the first problem right here says multiply f and g together. That's what that dot is. Okay, so I would set it up like this. I would have x squared minus 1 times x plus 1. So when they're expressions, you know, you put them in parentheses and you just put the parentheses right up against each other. Now, what kind of problem is that going to be? That's a box problem. Okay, so maybe somewhere over here in the margin, you want to go ahead and draw a box. And we're going to set up x squared minus 1 times x plus 1. Now, multiplying. When you guys multiply, exponents change. So x times x squared is not x squared. It's x to the what? To the third. And then if we take x times negative 1, we get negative 1x. When we go to do the bottom row, you've got 1 times x squared, which is just x squared. And then what's a positive 1 times a negative 1? Times.
Negative 1.
Negative 1. Okay, when you guys go to write out your answer, normally when we do a box problem, aren't there some like terms somewhere? I mean, normally there are, but are any of these like each other? No, none of them are like each other. So all we have to do is list out all 4 terms. Now, this is how I typically do it. I always start with my highest exponent, and then I work my way down. So like I put x to the third first, and then I put the plus x squared, and then I put the minus 1x, and then I put the minus 1. Does it necessarily have to go in that order? No. If you guys just did this, like x cubed minus 1x plus x squared minus 1, I mean, technically that's still right. I just prefer Most of the time you guys would see, if you ever saw it in like a textbook or on notes, they're always going to put it in descending order, meaning start with the highest exponent and work your way down. Okay, are we good there? Okay, well now this one says they still want us to multiply these two together, but they've given us a number. See how this one says x? See right there, they left the x in it. That means they wanted x to stay in your answer. But here, if they give you a number, what am I supposed to do with this number? What? No, not multiply.
Square root it. Divide.
Isn't this x? Plug it in for x. Okay, so if I take f, which was x squared minus 1, and we're going to multiply it by the g, which is x plus 1, they have just now given us the number to plug in for x. So look, we'd plug in a 2 right here, so 2 squared minus 1. What is 2 squared? 4. And what's 4 minus 1? 3. And then over here, since there's another x, I'd plug in a 2 there, 2 plus 1. And what's 2 plus 1? 3. So then what's 3 times 3? 9. Okay? So this is what I want you guys to understand. If you guys are doing these function operations, and you see a letter x right here, they want you to leave your answer in terms of x. However, if right here you guys see a number instead of the letter x, you are just going to plug that number in wherever you see the letter x and then do what the operation says. Okay, so sometimes they give you a number to plug in and sometimes they don't. It varies from problem to problem. Okay? Still, nothing we've done there is any different than what we've done in the past. We have done tons of substitution where I give you a number and you guys just do like a plug and chug. We have done plenty of box problems. So it's not like this is new. It's just written a different way. Okay? All right, then let's go over to the 2 division problems. For the 2 division problems, it says f divided by g. So put f up top and g on the bottom. Now, how can I factor the top? Because that's a quadratic. I'm not going to use the asterisk. What am I going to use?
Square root.
So difference of squares. So this is a difference of squares problem for us to factor. If you take the square root of x squared, what do you get? X. And then what's the square root of 1? 1. And one set would say plus, the other set would say minus. That's how you factor x squared minus 1. And then the bottom is just going to stay x plus 1. So do you see something that can cancel? What?
X plus 1.
This x plus 1 cancels this x plus 1, leaving just x minus 1 as the final answer. Okay, now this one, notice they gave us a number again. So we can still set it up the same way where we do like x squared minus 1 up top and x plus 1 on the bottom. But then instead of leaving the x in it, they want us to replace x with 2. So we're going to do 2 squared minus 1 up top and 2 plus 1 on the bottom. So now we will no longer have x in our answer. We're going to just end up with a number. What is 2 squared minus 1? 3. And what's 2 plus 1? And what's 3 divided by 3?
1.
1. So your final answer there would be 1. Okay, so far all we've done is add, subtract, multiply, and divide. Again, nothing different. I understand that the notation is a little bit different, but everything we've done up to that point is stuff that you guys have all seen before. When we get down here to the bottom, this is what we call composite functions. Okay, now composite functions, they're going to look a little strange. Notice right here, see that symbol? You cannot confuse that with a multiplication symbol. Multiplication, that would be a closed dot. Okay, if you see an open circle like that, that is what we call the composite of functions. So they want the composite of G with F. Okay, so what that means is you are going to take the innermost function, this one, we're going to take F, and we are going to plug it into G. Plug into G of X. It is just substitution. We are going to take one function and plug it into the other where the letter is. Whenever we say substitute, that means take the letter out and put whatever it equals in its place, right? So I'm going to tell you what f of x is, and you're going to plug it into G. Even down here it says evaluate the inner function first, so that was f of x, and then use that answer as the input of G of x. So we're just basically taking one function and plugging it into the other. Okay, so turn the page. These are the ones that you definitely need the most practice with because these are a little bit more difficult. Okay, so everybody watch. This one says, you know, here's f, which is x minus 2, and then g is x squared. Okay, so they want us to find the composite of g and f. Which one's on the inside? F. Okay, f is the input. Okay, we are going to take f and we're going to plug it into G. That's what we're going to do. Okay, so look, here's f. See f right here? That expression for f. We're going to plug it in to G wherever the letter is. So originally, G of x just said x squared. Well, instead, we're going to take this x out, and what are we putting in its place? We're taking x out and putting what in? X minus 2. You are plugging one function into the other. So you take the letter out and you put what I have in the box in its place. Now how do we do this? How do we simplify x minus 2 squared? X minus 2 squared means this. X minus 2 times another x minus 2. So what do I do to solve that? It's times. What do? We just using a box problem, right? This is a box problem. So you guys need to set up an x minus 2 times an x minus 2. What's x times x?
X squared.
And then x times negative 2.
Negative 2x.
And negative 2 times x.
Negative 2x.
And negative 2 times negative 2.
Negative 4. 4.
Yep. Okay, so now we're going to just write this out. So we have x squared by itself. And then if you have a negative 2x with another negative 2x, that's a total of negative 4x. And then you've got plus 4. So once we did our substitution, it just became a multiplication problem. It became a box problem. All right. This one over here. Notice how G is on the inside now? That's the input. So we're going to take G and we're going to plug it into F. So we're going to go the other direction now. So everybody watch me, please. I'm going to write these again because I wrote over them. This one says to take G and plug it into F wherever you see the letter X. So look up. Originally, F said X minus 2. That was the original F. But now what am I supposed to be plugging in where that X was? I'm supposed to be plugging in an X squared. Is there anything I can do to simplify that? Like, can you combine these two? No? So my answer is just X squared minus 2. Bless you. Bless you. So using the same two functions, if you do the substitution for both, sometimes plugging one into the other is super simple like this one. Like once we plugged it in, there was nothing more to do. But this one over here, once we plugged it in, we had to do a box problem. So sometimes even using the same two functions, it just really depends on which one is getting plugged into the other. Because sometimes it's real simple, sometimes you have to do a little bit of work. Are we good? Okay, let's do the bottom two. Do me a favor before we even start working on the one on the left. Take these two functions right here, copy them back down over here. I'm going to use these two on this side, and I'll use these two on this side. Okay, which one are we plugging in on the left side? Which one's the input? Okay, so I like to do this. Whichever one's the input, I like to put a box around because that is the one. So now watch. This is the one that I'm going to plug in right there. So G originally said something squared plus 7. That's what G said. But once I take this X out, what should actually go in these parentheses now?
1.
What am I plugging in right here?
X. X minus 7.
Plugging in the X minus 7. You're plugging one expression into the other. Okay, so now, look at this. If this says X minus 7 squared, what kind of problem is that? That is a box. We are going to take an X minus 7 times another X minus 7.
Seven times 7 is what, 49?
All right, so X times X is X squared. X times negative 7 is negative 7X. Negative 7 times X is also negative 7X. And then a negative 7 times a negative 7 is positive 49. Okay, so I need you guys to look up here. Everything in this box, the X squared minus 14X plus 49, takes care of this, okay? Takes care of this, but isn't there still a plus 7? So I'd want to bring that down. And then what can I combine?
Where'd you get 14?
Negative 7 and negative 7 makes negative 14. The 49 and 7 we can go ahead and add together to make 56. And that right there is your final answer. Now, when we plugged f into g, there was a little bit of extra work that needed to be done, right? We had to do a box, and then we had to combine some like terms. Let's see what happens when we plug g into f, because my guess is this one, if this one was a little bit more difficult, this one's probably the easier one. Okay, so this time it says take g, and they want us to plug g into f. So again, if g is the input, put a box around it. So here's g, right there. We're going to pick this up, and we are going to plug it in to f where the x was. So if my original function for f said something minus 7, so x minus 7, what am I now putting in place of the x? X squared plus 7. Now that one's way easier, because what can I combine? The 7 and the minus 7? What's 7 minus 7? They cancel each other out, so aren't we just left with x squared?
Mm-hmm.
That one was way easier than the other one. So like I said, if they give you the same two functions, but they tell you to plug them in differently, usually one's pretty simple and the other one might be a little bit more complicated. Okay, last 4 problems, last 4. More composite. What does this one say? What do they want us to plug in? They want us to plug G into G. They want you to plug G into itself, which sounds really strange, but up here at the top, go ahead and copy down G again. I know it's already here, but if they want me to plug a G into G, I like to see it. Like, I like to physically see, okay, here, the negative 3x plus 5 is what I'm going to plug in over here where the x is. Okay, so I would start with negative 3, and then I'm taking x out, and what goes in its place? What goes in here? Negative 3x plus 5. Whatever's in this box is getting plugged in right there. Okay, so what am I going to have to do here to simplify this? Right here.
The claw.
Distribute. Right? The claw. What's negative 3 times negative 3x?
Negative 9x.
9x. And what's negative 3 times 5?
Negative 15.
And then bring down your plus 5. And then we can just finish by combining these two. What's negative 15 plus 5?
Negative 10.
Negative 10. Good job. Now this next one is kind of difficult. This one says we're going to take G and we're going to plug it into F. So we're going to take this, the negative 3x plus 5, and we're plugging it over here into F. So here's, don't write anything down, just watch real quick. Here's the original F. 4, then something is going to be squared minus 6. That was the original. I just am leaving this blank because I know I'm taking that x out. And what am I supposed to be putting in here? Negative 3x plus 5. And I want you guys to look at the difference between how I wrote this, because over here, I just distributed because there was a number in front of the parentheses. This one has an exponent. And in the order of operations, do you do multiplication first or do you do exponents first?
Exponent.
You have to do exponents first. So actually, we've got to do this part first. And then whatever we get from that, then we'll multiply it by the 4. Okay? Well, what kind of problem is that? It's a box. It's always a box. Well, there's a lot of box problems we do. So we have a negative 3x plus 5 times itself. So start filling out that box for me. Remember, when you multiply, your exponents change. So negative 3x times negative 3x. 9x squared. Negative 3x times 5. And then 5 times negative 3x. And 5 times 5. Okay, so when I rewrite this, I've got the 4 out front. Then all of this goes in here. 9x squared. If you put these two together, that's a total of negative 30x. And then I have plus 25. And then I still have that minus 6 at the end. So we've made the box. Now we have to distribute, so you guys need to multiply 4 by all 3 of those terms. So start multiplying for me. What's 4 times 9x squared?
36.
36x squared, yep. 4 times negative 30.
Negative 120.
Yep, negative 120x, and then 4 times 25. You all know, because if you have 4 quarters,
100.
you have $1. Yep, so it's 100. And then bring down the minus 6. Then what can we put together?
The 106.
We can do 100 minus 6, which is?
106.
No, subtract it.
Oh, 94.
94. There's our final answer. That one definitely required the most work out of all the ones we've done so far. Because you had to do a box, then you had to distribute, then you had to combine.
Wait, so how'd you get 9 though?
Negative 3 times negative 3 is 9.
Oh.
You had it written down. Yeah. All right. Now, the 2 bottom ones are also composite, but look at what it says. It says they want you to take G of 1 and plug it into F. So first of all, we have to figure out what G of 1 is. So we're going to take this over here, and we're going to plug a 1 in. So negative 3 times 1 plus 5. What is negative 3 times 1? Negative 3. And what's negative 3 plus 5?
2.
2. So what they're telling us is, okay, take the number 2 and plug it into F. So now I'm plugging the 2 in right here where that X is. And you guys could just type that directly into a calculator.
4 times 4 is 16.
Yep, 10. Yep, answer is 2. Or 2, 10. 2 was the number that we plugged in, and then we got an answer of 10. That right there is the final. It's not too bad when you have to plug in a number. It's actually easier plugging in a number than it was doing these up here. And then the last one, they want us to find f of negative 2 and then plug it into G. So f of negative 2 equals, we're going to write this down, plugging in a negative 2 where the x was, and we're going to simplify that. I would just type it into a calculator. Whenever somebody does, you just let me know what it is.
4 times 16.
10?
Yeah.
Okay. So f of negative 2 is 10, And they want us to take that answer and plug it into G. So now I'm going to find G of 10. So I'm going to take -3, I'm going to plug in a 10 where the x is, and then add 5. So what is -3 times 10?
-30.
Plus 5.
-25.
-25. And that's the end of your first lesson.